Today I'm going to show you how I go about setting up a forged weld, and today I'm going to be demonstrating a drop tong weld, which I think is probably the most intimidating weld for smiths that are just starting out. But you'll see by the end of the video that there is a process that you can work through and it isn't that bad. Hi, I'm Dennis Frechette and welcome back. In this video, I'm going to be focusing on one aspect of forged welding, and that is what I call the initial tack weld. You haven't really made a full weld yet, but you've got the pieces stuck together enough so that you can handle them as one piece and put it back in the fire and continue the forge welding process from there. Now, there's a lot of different opinions about how to go about making a forge weld, what's important, what isn't important. But I think everyone will agree that if you can't get the two pieces to stick together, you've got nothing to work with. So that's what I have for you today, and hope it helps you out. Today I'm going to be doing this demo with a couple of pieces of flat bar. You can use whatever you like, of course, but I would recommend using something like 1/4 by 1/2 inch flat bar because it's light enough that it'll allow you to go through the heat cycles fairly quickly, but it still has enough mass to give you that few extra seconds that you need to get over to the anvil and put these two pieces together. The areas of the bar that are going to be forge welded together need to be thinned down slightly so that the completed forge weld can be hammered back down to a seamless bar. This is usually referred to as the scarf, and in every forge weld that's approached in a slightly different way. Here I'm doing the bare minimum setup. I'm just hammering a slight chisel edge on the end of each bar, and I'm going to be forging the flat faces together. So this is by far the most basic forge weld that you can get. The first thing that you need to have when you're forge welding is a really thorough understanding of how the forge fire works. That knowledge will first of all allow you to build a good forge fire and more importantly to maintain it. Now that's a pretty lengthy topic and I've made another video that covers all that. So if you haven't seen my how to manage a forge fire video, I'll have a link for it in the description. Now you don't have to watch that video before you watch this video, but I highly recommend that you watch it before you try to do any forge welding because that video teaches you how to build and maintain the fire. This video tells you why it's important to build a good fire and maintain a good fire. And the problem with all that, of course, is that it's hard to show you the cross-section of a live fire to explain what's going on inside that fire, and more importantly, how that fire evolves as the coal is being consumed. So what I've done is create a series of drawings, and hopefully they'll, help to explain the finer points of what you need when you're trying to forge weld. This first slide shows the cross-section of a good working fire. I have the air coming in from the bottom here because that's how my forge is set up. If you're using a side blast forge, this cross-section would look a little different, but the principles would still be the same. The green arrow is pointing to the white area towards the bottom edge of the forge, and that's the oxidation layer. This is the hottest part of the fire, but it's also the part of the fire that has the most oxygen. So any piece of steel that drops down to this level will start to burn very quickly. The area directly above and surrounding the oxidation layer is called the neutral layer. Now, the temperature difference isn't quite as dramatic as I've illustrated here, but the important thing about this layer is that it is consuming all of the leftover oxygen that's passing through the fire. So in an ideal world, there should be no available oxygen here to affect the metal that you're working with. So at this level, you get a really hot fire and the chances of burning the metal are extremely low, provided that you keep the fire really tightly packed. Now the red and the gray areas are also neutral zones, but the red area is just not hot enough to really heat the metal up much, and the gray area is representing mostly the unburnt coal that is working its way to the center of the fire. So it's basically an insulating layer. And this slide illustrates why I like to stop cranking the blower every once in a while I'm heating something up. When you shut the air blast off, the oxidation zone disappears and the heat between the oxidation zone and the neutral zone equalize. So you can have a piece of metal sitting in there for quite some time unattended without any danger of burning it up. Because the steel can't get any hotter than the coals that are surrounding it. So I'll let the bar sit there. Every once in a while, I'll come by, crank the blower a bit to perk up the fire. But most of the time, the bar is just sitting in hot coals and it's coming up to temperature very slowly and safely. And finally, this is what happens to a fire if you haven't paid any attention to it for a couple of minutes. The air blast is starting to consume all of the coke in the center of the fire, and that, of course, means that the volume of coke is getting smaller in the center of the fire, and there are passageways that are opening up that allow the air to move much higher in the fire than it did before. So if you don't recognize the problem and correct it early, the oxidation layer will just keep moving up in the fire until it totally consumes the center of the fire and leaves this void that you can't work with. Once that happens, the only way to repair it is to push the sides back into the center and start rebuilding your fire, reestablish the oxidation zone and your neutral zone, and then you can have a fire that you can work with again. But maintenance is the key to preventing this problem in the first place. So here's the actual forge that I'm working with, and I do have the fire set up as I described in the first slide, and it just looks like a pile of coal with a little bit of flame coming out of it. And the reason I showed you the cross sections is because every one of those fires would look pretty much like this from this vantage point. So you'll just have to trust me when I tell you that I have the forge set up the way you see it in the top right hand corner in the screen, and I have the bars in the fire, and I'm slowly raising the temperature until they get just below a welding heat. So it's a very, very light yellow. Once I get to the anvil, I'm going to use my wire brush to clean off all of the scale, and while the bar is still hot, I'm going to apply flux to every side of the bar. Now the bar is very hot at this point, so the flux is going to dissolve very quickly into a liquid, and I usually stop applying flux when I notice that the bar is cooled slightly and the flux is not dissolving totally. And I'll repeat the same process for the other bar. The flux that I'm using is just regular 20 mule team borax that you can find in your detergent aisle at the supermarket. I haven't done anything to it. This is just straight out of the box. Now I'm ready to start heating up the bars to bring them to a welding temperature. I'm going to be placing both bars high up in the neutral zone as I did earlier, but this time I'm making sure that they're at the same level and they're not touching each other. I'm going to quickly use the poker to push the sides of the fire towards the center to fill any gaps that might have developed in the last heat. And then I'm going to use my spoon to rake more raw coal around the outside edges of the fire so that it can start turning into coke, and I have it ready for the next time that I need to push the fire towards the center to fill up any gaps. And that just becomes the routine around the forge. It may seem like a lot to remember, but in no time it'll just become muscle memory and you won't even realize you're doing it. At this point I can crank the blower a little bit more than I normally would to perk the fire back up, and then once I see that the fire has a good head of steam going and the bars are starting to heat up, I will really throttle back on the blower and just give the fire enough air to keep going. You are going to notice that the bars are going to heat up a lot faster in this heat because even though they may look cold going in, the core temperature of the bar is still quite hot, so they're going to accept the heat very quickly. Here I'm a little bit further along, and I've been spending the last couple of minutes slowly raising the temperature of the fire by cranking the blower a little bit and then easing up on the blower and stopping entirely at some point so that I can let the temperature of the fire equalize, and then I would just keep following that cycle until I'm right up at the welding heat. It's a bright light yellow. There's barely any color to the fire or the steel. Everything is the same temperature, and I am ready to pull the bars out from the fire. I'll be picking up the short bar first with the pair of tongs because that usually takes 2 hands, and you need to make sure that the tongs are in your hammer hand. Next, I'll pick up the long bar and head over to the anvil. When I get to the anvil, I'm going to make sure that the 2 flat faces are together and the short bar is underneath the long bar. And then I'm going to wiggle the long bar slightly until I feel some resistance. At that point, I can drop the tongs, pick up the hammer, and tap the weld slightly at one point. That's just to make sure that the 2 bars are stuck together enough that I can continue the process. This joint is a little longer than I'd like, but don't worry about that stuff now. Just concentrate on getting the 2 pieces together. So even though I can treat the bar as a single unit, the strength of the weld at this point is probably the equivalent of 2 or 3 wraps of duct tape. So you still have to be careful. So for this heat, I'm going to be repeating exactly the same process that I used for the first heat, only this time I'm going to be working with 1 bar instead of 2. I'll be bringing the bar back up to close to welding temperature so I can take it to the anvil, scrape off the scale, and apply more flux. The flux is only capable of dissolving a certain amount of scale before it stops working, so it's important to remove it and replace it often while you're welding. Once again, I'm following the same procedure here that I've used all along for bringing the bars up to a welding heat. At this point, I have part of the weld tacked together, so I have good contact in that one area. So what I need to do in this heat is hammer along the entire length of the weld to make sure that I have full contact across that entire area. And the reason I'm doing this in a couple of heats is because, as I mentioned earlier, the joint is a little longer than I would have liked, and I just don't have the mass to give me the working time to do the tack weld along the entire length. So in this heat, I'm going to be lightly hammering over the entire surface, making sure that I have good contact along the entire joint. I'm going to pay special attention to the thin edges of the scarf joints. They should be blending into the bar at this point, and basically just starting to refine the shape a little bit and getting ready for the actual first true welding heat. It's important to realize that now that I have good, clean contact between the entire weld joint, every minute that I spend at welding heat and every heat cycle that I take it through from below critical to welding temperature, all of those things are going to contribute to the strength of the weld. You should also notice that the 2 bars that I started with are still clearly visible. I haven't done any heavy hammering yet. I'm just doing light, firm hammer blows to encourage the 2 faces to push together. The contact of the 2 faces, the heat, and the time are going to do more to create a good weld than heavy hammering at this point. Once you have a good tack weld set up, then you can go into the heavier hammering that you're going to use to actually shape the weld. But I know from experience that if you rush through this process, the strength of your final welds are going to suffer. Here I've cut the weld from the bar, and you can see that I have the finished weld in my tongs, and I'm starting another weld on the other end of the bar. And I'm just going to quickly run through the process again so that you can concentrate on the visuals without a lot of me talking in the background. So here you can see that I had a fleeting moment of coordination and I was able to set a weld with a much shorter overlap than I did with the first weld. And that's going to allow me to get a lot more work done in this heat. I was able to tack the weld and set both scarves in one operation. This is a good length for this weld, so it's what you're aiming for. But when you're starting out, don't worry about that stuff. Just get the two pieces together. If the lap turns out to be a little longer, you just need to take another heat. It's not a big deal. You're still going to get a good weld out of it. This is the sample of the welds that I just completed. The one closest to my hand is the first weld that I did with the overlap that was much longer, and the one at the other end of the bar is the second one that I did with a much shorter overlap. You can see how the first weld that I did isn't quite as far along because I have to take two heats to cover the full length of that weld, whereas the second heat, my hammerhead covered the whole length of the weld, so I was able to get a lot more work done. Here I have the bend test that I did for these two welds, and you can see that even at this stage, there has been enough metal transfer to create a strong enough weld to bend the original bar stock. Now you have to understand that these are just test pieces and they are just tacked together, so I wouldn't normally be bending them at this point. I'm just trying to illustrate that even though they are just tacked together, they are still fairly strong. To complete the weld, you need to bring these bars back through at least 2 or 3 complete welding cycles to fully develop this weld. The weak point in the bar right now is right along the weld line. So if I continued to flex these bars, they would eventually break and they would peel apart right along the weld line. That doesn't mean that the weld is bad. It just means that you haven't taken the time to fully develop the weld. In this next sample, I've let the height of the fire drop down quite a bit. It's still above the edges of the fire pot, so it's probably deeper than most people try to use for forge welding, but you can see how the neutral zone has really diminished in size. And even though technically it's still there, it's so close to the oxidation zone that it is being contaminated from the extra oxygen running through the fire. So if this fire looks familiar to you, it's probably the reason you're only getting welds to stick about 20 or 30% of the time at best. The border between the oxidation zone and the neutral zone is just too close, and it's probably always moving. If the oxidation zone drops a little bit, you're going to get welds to stick, and if the border moves up a little bit, nothing's going to work for you. So this time the weld did stick, but I could tell that there wasn't the same amount of grab that I had in the first 2 welds that I did under ideal conditions. So here's a sample for this weld, and you can see how the ends of the weld, the scarf joints, are still a hard line. They should be blending into the rest of the bar, but even at this stage. So there is evidence that there are problems with this weld. And the bend test shows that it took absolutely no effort to break this weld. The 2 dots in the center of the weld that look like center punch marks are actually the only area of the weld where there was any metal transfer. So those 2 dots were actually holding the weld together. Everything else, there was clean metal, but they just weren't sticking. In this example, I've let the height of the fire drop down even more, so you can see how there is virtually no neutral zone, and you have no choice but to be working in the oxidation zone. You can still forge in a fire like this, but there is absolutely no way that you're going to be able to get more than 1 out of 10 welds to stick in an oxidation fire like this. When I pull the bars out of the fire, everything looks good, but when I stick the 2 pieces together, I'm feeling absolutely no grab. There has been an oxidized coating that has gone right through the flux layer and has created a barrier that is going to prevent these bars from welding. There isn't anything you can do. And here's my second attempt with the same bars. Again, everything looks good, but I'm not feeling anything grabbing and they are just not sticking. In this example, I've rebuilt the fire back up to the height that it was in the first sample that I did, and I'm going to be working with the bars that I couldn't get to weld in the last two examples, just to illustrate that the process is reversible as long as you didn't do any permanent damage to the metal. So the only prep work that I'm doing to these bars is I'm going to be scraping off all of the old contaminated flux and reapplying the flux and putting them in a proper fire and just doing the whole thing over again. So once again, coming out of the fire, everything looks good, but fortunately this time I'm feeling the two bars grabbing each other and I just give them a little tap to reinforce that bond and I know everything's fine. So this is the finished weld. It's not as clean as the first weld that I did with new material. There's obviously a bit of evidence of pitting and a little bit of damage done from the first two failed attempts at sticking this weld. But there are edges that are starting to blur, and the bend test does show that I did get good surface contact and there is the potential to have a good weld here. So don't be discouraged if you miss your first or even your second attempt at getting the welds to stick. You do have time to regroup, reset your fire and get a good weld out of it. The important thing is to keep practicing and just concentrate on getting the welds to stick first, and then everything else is going to fall into place.